Well, here they are, guys. The structural plans for my shipping container home. I can say without a doubt that this was one of the most challenging and time-consuming phases of this DIY project so far. So let's go ahead and break all the details down, and I'll be revealing to you how the whole structural phase came together. Building my own shipping container home. Join me on my journey from construction to completion of my mortgage-free home on a homestead. This video is part 2 in a 3-part series. In the last episode, we covered the architectural plans. Today, in episode 2, it's structural, and the next video, part 3, covers the mechanical, electrical, and plumbing plans. So here we go, the structural plans. Basically, I can say without a doubt that this was the most time-consuming of all the plans. The reason? Well, I think I can sum it up with the phrase trial and error. You see, it's one thing to draw up a home that looks pretty. It's something else to design a home that's structurally sound and code compliant. And again, this is why I decided to fork out the $1,000 to hire a professional structural engineer. Where I could design the looks of the house, the engineer could provide feedback in case anything I had in mind didn't live up to the structural calculations and code. My home is going to be made of 3 40-foot high cube shipping containers. Some of the walls will be cut out to open up floor spaces and to create windows and doors. A concrete footing and pedestal system will be used as the foundation. I do not plan to add an extra roof on top of the containers, but that doesn't mean I don't need a reliable, structurally sound, and code-compliant ceiling system with beams and rafters. In fact, that was the most time-consuming phases, the design of the ceiling rafters. But let's start with the foundation. Concrete columns are a common and cost-effective approach for securing container homes. As you can see in this final 3D model I created, which you can download using the link in the description below, this is what the foundation columns will look like, down to the base plates, non-shrink grout, and anchor bolts. There's a total of 16 columns, all identically sized. In my county, I was required to have engineered plans that were stamped and signed by a PE in the state of Florida. So even if I wanted to just wing it and do my own thing, it still would have required approval from a pro in order to get approved. There's a total of 16 columns, all identically sized. Part of making the foundation code compliant was ensuring it was sufficient for Florida's hurricane force winds. From what I gathered from my engineer, a combination of soil type and expected wind speed played the biggest role in determining the size, thickness, depth, and amount of embedment of the columns. There are 2 main components to the columns, the footing and the pedestal. We ultimately settled on a 3-foot by 3-foot by 15-inch footing, and then a thinner pedestal extending up above it to hold the containers. To see all the size and structural details for the foundation, click the link below to download all 6 pages of the structural plans my engineer created. They include drawings and structural details about the foundation, rafters, and the beam systems, the ceiling, openings, and much more. Just click the link in the description below to access all the plans. On top of the pedestals, a layer of non-shrink grout and a base plate is secured in place by large anchor bolts that extend down into the pedestal. Then, the corner fittings of the shipping containers are welded to the base plate. One of the most challenging aspects in creating the foundation was a little something called the water table. A water table is the point where water is found. In the case of my land, over the area where the house will be, the water table is about 40 inches underground. As an assumption, I figured pouring concrete and constructing the columns would be even more challenging if the depth of the columns met the water table. Now, I have heard that there are many ways to create concrete footings past the water line, but it seemed to be an extra nuisance, better off avoid it altogether. So I was faced with an issue. On one hand, I preferred the bottom of the columns did not go below the water table, but at the same time, if I raised the columns too high, there wouldn't be enough soil to bury them in, also known as embedment. My structural engineer requested 30 inches of embedment, so the pedestals couldn't be too high, otherwise I'd have to start adding soil in the area on the ground where the house goes. But there was another factor to consider: the septic system. That's right, Out in the rural area where I'm building the container home, you're required to have a septic system. The reason this was an issue with the foundation was that in order for wastewater to flow from the house through the drain pipe and into the septic system through, quote, gravity alone, the container home would have to be at a higher elevation than the septic system. So before I could even determine anything about the foundation, I needed to know the final location of the septic system. Now, this might seem like it was a bit complicated and crazy, but really it wasn't that bad, and it really just a matter of taking your time. It's not too complex. Of course, I will be doing a video on the entire septic system when that time comes, so be sure to subscribe and hit the bell notification down below so you're notified when I upload that video. But for now, I'll just say that in my county, septic system permits are issued through the Department of Health. It costs $500, and they send an expert to your land to dig holes and analyze soil and determine the depth to the water table, and they even leave something called a benchmark, which in my case was a nail hammered into a tree trunk with a bright yellow dash of spray paint. This benchmark is used as the reference point during the construction of the septic system to determine how deep it has to be, etc. So once I had that information, I now had what I needed to reverse engineer the elevation of the container home above the septic system. Whew. Now let's move on to the walls and ceilings. As you can see, I plan to tear down a significant amount of the container walls. The main reason was to increase the spaciousness of the entryway. I was inspired by a container home I saw on the Living Big in a Tiny House YouTube channel. I wanted there to be a sense of spaciousness when you entered, and the standard 8-foot width of a container wouldn't cut it. By tearing down a portion of the walls on all 3 containers, I had the open floor space I wanted, but there was a price. Basically, it all comes down to how far the rafters can span without a vertical support for them. Ceiling rafters are basically the structure that holds up, well, the ceiling. This includes the weight of the drywall, light fixtures, fans, etc. However, the further a rafter has to span without some kind of vertical reinforcement to keep it up, the bigger the rafter itself has to be, in this case, taller. But here's the issue. The taller the rafter, the more space it takes up, which effectively drops the height of the ceiling. The standard height for a ceiling today in the average home is 8 or 9 feet. So that was at the very least what I was aiming for. And at the end of the day, what's the point of putting the extra money in for a high cube, a slightly taller shipping container, if you're not going to have a decently sized ceiling? The issue came when the container walls I removed created a span so far that the rafters had to be so tall that they dropped the height of the ceiling below 8 feet. For example, this long stretch with no walls from the front door to the back door measures about 22 feet. According to my structural engineer, if I wanted to use wooden rafters that span 22 feet, the rafters would have to be 2 by 12 inches, 2 inches thick by 12 inches tall. A 12-inch tall rafter would have dropped the height of the ceiling well below 8 feet, so we needed to find another solution. Alternatively, for this much smaller span of about 15 feet on this side of the house, the structural engineer said the rafters could be 2 inches by 8 inches, which was just about perfect for an 8-foot tall ceiling. So now I just needed a solution for this long 22-foot span here and here. And what followed was a few weeks of back and forth between I and the structural engineer as we sort of fleshed out these details. One of his suggestions was to replace the wooden rafters with steel and I-beams. Basically, the material and the shape of these I-beams allow for a much longer span, yet still a smaller size. Where a wooden rafter could be no less than 12 inches tall on a 22-foot long span, a steel I-beam could be as small as only 5 inches tall for the same 22-foot long span. 5-inch tall steel I-beams for the entire ceiling system would have been perfect for my needs, except for one problem: cost. According to one quote from a local steel producer, a single 20-foot I-beam would cost $513, not including shipping. Needless to say, to use that across the entire home would cost easily more than $5,000, simply out of the question. I researched a ton of alternatives, including these wooden I-beam rafters that are shaped like a steel I-beam, but made entirely out of wood. Because if you didn't know, what gives steel beams their strength is the eye shape. Well, it turned out that even these eye joists, also known as engineered wood, couldn't manage a 22-foot span at the size I needed. Many more hours of research and tinkering led to a completely new solution. What if there was a way to create a support for the rafters that broke the long 22-foot span? If we could just minimize the length of the span somehow, we could minimize the height of the rafters. And eventually we found our solution. Place an I-beam right here, perpendicular to the wooden rafters, crossing the entire width. Now we would have about 15-foot long wooden rafters, only 2 inches by 8 inches in size, on this side of the steel beam, and then short, roughly 6-foot long rafters to go the rest of the way. The steel I-beam will only be 8 inches tall, so it fits perfectly in the ceiling with the 3x8 wooden rafters, and it is supported on either side by 4-inch by 4-inch by 1/8 of an inch hollow tube steel. The tubes fit perfectly within the 4x4 wall studs, so it all works out pretty well. Then I can do the exact same thing over on the bathroom side of the house, and all I'll need is this one small beam, way better than the original additional $5,000 to make it all steel. And then there was one last hiccup at the last minute that almost jeopardized the progress we were making. Basically, I had determined the limit of how tall the rafters could be based on my understanding at the time of the internal height of a shipping container. And I found that number by Googling it. Numerous sources say it's 8 feet 10 inches. But I'd overlooked something very important. These long top rails that run across the containers are actually a bit lower than the corrugated roof of the ceiling, which is what the online sources were referring to. And since the rafters ran as long as one continuous span of about 16 feet, they would have to be placed just underneath the top rail and not up against the corrugated ceiling. Luckily though, even with this slight difference in elevation, the numbers worked out and the ceiling is within a fraction of an inch of 8 feet high. This is without a doubt another benefit of having a fully fleshed out 3D model. It allows you to catch subtle errors or issues that you might otherwise overlook. From the location of drain pipes between container beams to the positioning of foundation columns, this 3D model was one of my greatest resources. And so that just about sums it up for this episode on the structural plans for my shipping container home. Again, all the extra details from the rafter systems to the structural foundations, to the exact specific dimensions, the opening systems for the various doors and windows, all these details are available to download right now. Just click the link in the description below to learn more. So again, thank you guys for watching. In the next episode, part 3 of 3 in this 3-part series covering the detailed plans, I'll be revealing to you guys the MEP plans, mechanical, electrical, and plumbing. And that was another pretty tough one as I went back and forth with the engineer, but I've got the plans, I got the details, and I'm going to be revealing that for you guys in the next episode. So again, click the subscribe button and the bell so you're notified when that video comes out. And as always guys, anything's possible when you think outside the container. Talk to you guys later.